Today is going to be section 80-1. We're going to be taking a look at function compositions. So today's objective, we're going to take a composition of different functions. Now, throughout class, we have examined various types of functions and how to manipulate them. Like we added them together, we subtracted them together, and we're going to take this entire unit and we're going to devote it to examine unique types of functions and how they're created. Now we're also going to take a look at how we can manipulate these functions as well. Now one of the first topics that we're going to talk about is this function composition. And it's actually a new way for us to be able to combine these functions together. And so by definition it says that suppose f and g are two functions. The composite of g with f denoted by g of f. So this is symbology that we're going to have to be able to use here. And says it's defined by the formula g of f of x equals g of f of x. These mean exactly the same thing. They're just a different way of writing it. Provided x is an element of the domain of f and f of x is an element of the domain of g. So it just means that this has to be the domain of this function, and which means this has to then be the domain of this function here. So the domain is going to be something that we need to pay attention to as we go through this entire process. Now this is kind of like a visualization process of what's happening. I plugged x into my f function, then I took whatever my f function was and I plugged that into my g function. And so that process is this composition. Now let's kind of visualize this, because the concept of function compositions isn't difficult, but visualizing it can be. And so going through this process, it might help us. Now if I were to say that I wanted to have this function f of x equals 3x plus 5, and I said g of x equals x squared. Now if I said I want f of 5, that means I was saying take my f function and plug 5 into it. And so I took my f function, which was 3x plus 5, and I plugged 5 into it, and you would simplify that, that would be f of 5. Now if I asked and said, what if I want f of x plus 2? That means that I would take this x plus 2 and I would plug it in for x into my function. And so instead of writing 3x plus 5, I would write 3 parentheses x plus 2 plus 5. Now what if I wanted to say I wanted f of g of x? Now you would plug in g of x in for x. This g of x here, you consider that an input. So whatever g of x is, that's what you're plugging in for x. So if I said f of g of x, that's the same as f of x squared, because g of x we said equaled x squared, and so that would turn into 3x squared plus 5. Now that's the way that I want you to envision it. When we're saying, like in this case, f of g of x, this g of x represents a function, in this case x squared, and you're taking that value and all you're doing is you're plugging it into your function, replacing whatever variable that function is currently representing. So let's take a look at our first example. It says, let our f function, g function, and h function be defined as these values here. It says find the indicated function value. So this is g of f of 1. So that means I could take 1. Another way of thinking about it is g of f of 1. And so what it's asking me to do is to take this 1 and plug that into my f function. So if I were to find what f of 1 is, I'd take in 1, plug it in my f function, so I get 1 squared minus 4 times 1. So 1 minus 4, so that equals negative 3. So if f of 1 is the same as negative 3, this now becomes g of negative 3. And so now my g function, we said, is 2 minus the square root. Now we said we have to plug in negative 3, so instead of x, I plug in negative 3. And so this would be 2 minus 0, which is 2. So this statement here equals 2. Let's take a look at part B. This is saying now f of g of 1. So we take 1, plug it into our g function, right? Because another way of looking at it is this, and then I take that and plug it into my f function. So let's start with that first part. Let's start with g of 1. So plugging that, I get 2 minus the square root of 1 plus 3. And so that gives me 2 minus the square root of 4. Square root of 4 is 2. So I get 0. So this is the same as f of 0. And now plugging in 0 into my f function, that's going to give me 0 squared minus 4 times 0, which is just 0. So f of g of 1 just gives me 0. Right, so for example number 2, we still have our functions defined the same, except now not only are we trying to find the composite function, but we're also now going to state the domain. Now when we try and find and state the domain, after we find the composite function, before we do any forms of simplification, we want to find what the domain is going to be. So the unquote-unquote simplified form, that's what we're going to focus on trying to find our domain with. So the first says g of f of x, so g of f of x. Well, it's asking us to take x and plug it into f. Well, that's not going to change anything. So now it's asking me to take my f function and plug it into g. Well, my f function we said was x squared minus 4x. So I'm going to plug x squared minus 4x into my g function. So that's going to be 2 minus the square root of x squared minus 4x, and then I have that plus 3. So this part right here, this was the original x. That used to be x there, right? If we're talking about it, see, I have the 2 minus the square root's the same. Instead of x, I now wrote what I plugged in, which is the x squared minus 4x plus 3. Now this is technically considered my unsimplified form. Now there's nothing I can do anything further with this, so this is, a correct response because I can't simplify that, but now I have to consider my domain here. And so with my domain, we have to consider what types of restrictions do I have. Am I dividing by an x in any fashion? Well, the answer is no. Do I have any x inside of a square root? The answer is yes. I have the square root of x squared minus 4x plus 3. So remember, when I have a square root, you take whatever's inside the square root, and you have to say it's greater than or equal to 0. So now this is a quadratic inequality, or a polynomial inequality, and so when it's a polynomial inequality, we have to find the zeros, and we put them on the number line. So factoring this turns into x minus 3 and x minus 1. So my zeros are going to be 3 and 1. And because it's equal to, it's going to be closed circle. And so plugging in values, if I plugged in, let's say 0, you get negative, negative, which is a positive. If I plug in 2, you get a positive and a negative, so that's negative. If you plug in 4, you get positive, positive, so it's going to be a positive. And remember, it says values that are greater than 0. Values that are greater than 0 are positive values. And so that's going to be my solution. And so then my domain here, that's going to be from negative infinity to 1 union from 3 all the way to infinity. And that's the domain. Now part B. This one, it seems like they might be the same, says f of g of x, but they're not. So don't just naturally assume that those are going to be the same. So in this instance here, now I have to take my g function and plug it into my f. So this is f of g of x. So if I take my x function and plug it into g, or my x and plug it into g, well, that doesn't change anything. But now I want to take my g function here and plug it in for f. So if I do that, I'm now going to get 2 minus the square root of x plus 3 squared minus 4 times 2 minus the square root of x plus 3. So let's kind of like take a step back. There's my x's. So we have x squared minus 4 times x. And so what I did here is I took my g function, which was 2 minus the square root of x plus 3, and I plugged that in for x into my f function. So I plugged it in for x, plugged it in for x. And so that's going to be my unsimplified version here. So right now, this is not simplified. So now this would be a good time to take a look at domain restrictions. So my domain, if we were to examine it, I'm not dividing by x in any form, but I do have x inside of a square root still. So I can say that x plus 3 is greater than or equal to 0. Minus 3, x is greater than or equal to negative 3, which means that's from negative 3 all the way to infinity. So that's going to be my domain. But now we have to do the exhaustive procedure of simplifying this. Well, I can distribute this negative 4 through, and that's going to give me negative 8 plus 4 square root of x plus 3. But now on this is FOIL. This is 2 minus square root of x plus 3 times 2 minus square root of x plus 3. So if I do first, I get 4. Now outer and inner, so 2 times negative square root of x plus 3, negative square root of x plus 3 times 2. So that gives me minus 4 square root of x plus 3. And then last, so that's going to be plus, and that's going to be x plus 3 in parentheses, because the square roots are the same, and so those are going to cancel out. So now seeing how things combine together, well, I have a negative 4 square root of x plus 3 and a positive 4 square root of x plus 3, so those are going to cancel out. And then I have a 4 and a positive 4, so that's 8, and then I have a minus 8, so those are going to cancel out. And so I'm just left with x plus 3. And so that would be my answer for B. For part C, it says g of h of x. So now for this, we take our x, we're going to plug it in for h. Well, it's going to stay the same. So then I can look at it as g of h of x. And so now I'm taking my h function and plugging it in for g. So for my g, it's going to be 2 minus the square root. Now instead of x, we're plugging in our h function, and so that's going to be 2x over x plus 1. And then I still have this plus 3. Now this is our unsimplified version, and there's not much else that we can do to actually simplify that. And so this would be our answer. And so now we get to do the fun part of finding our domain. And so our domain here, first, we have to say 2x over x plus 1 plus 3 has to be greater than or equal to 0. Now that this is a rational inequality, we have to try and combine these equalities together. So to do that, this needs an x plus 1 over x plus 1. Now that they have the same denominator, I get 2x plus, distributing that 3, 3x plus 3. That's all over x plus 1. And this is greater than or equal to 0. So that gives me 5x plus 3 all over x plus 1. So now my 0 on top, if I set the top equal to 0, I'm going to get negative 3/5, because if I subtract the 3, divide by 5. And then my undefined value, I get x cannot equal negative 1. So I have to create that number line again. Creating that number line, I have negative 1 here. We said it can't equal that, so that's open circle. And then I also have negative 3/5, and that's going to be a solid circle, and that's going to be 0. But that's not an actual value. Okay, so now that I have those values on the number line, now I got to plug in values. So if I plug in negative 2, that's going to give me a negative and a negative. So that's going to be a positive. If I plug in a value between negative 1 and negative 3/5, like negative 4/5, that's going to give me a positive on the bottom, but a negative on the top, so that's going to be negative. And if I plug in 0, that's going to give me a positive. So my region that I'm looking for is this region and this region. So my domain is going to be from negative infinity to negative 1 union, and then from negative 3/5 all the way to positive infinity. Now just remember that 0, that was just a marker because I was trying to show you that negative 3/5 was, 0 is on that side of it. And so there's my domain. So I have my composition and my domain. Now I'm just going to reference what we can do for part D with the composition. I think we understand domain now. So I'm just going to focus on the composition parts. So we can take the same function and plug it into the same function. That's an okay thing. So taking h, plugging it in for h. So visualizing this is h of x. Well, I take h of x and plug it in for h. And so the way that that's going to look is 2, well, instead of x, we said we're plugging in our h function. And then 2x over x plus 1 plus 1. Now this is a complex fraction, and so we have to take the steps to simplify the complex fraction. But just noticed where I had x, right, we said x is here and here, so there's my x, 2x over x plus 1. So you can take the same function and plug it into the same function. But as you can see, instead of asking me to say h of 2x over x plus 1, it's so much easier for me to say h of x. It makes the entire process so much simpler. And you can actually take a composition of multiple functions. And so the way that we read this is we always basically start on this side, and it's taking one and we're plugging it into the next, and we're plugging it into the next. So what this is saying is h of g of f of x. And so what I'm actually doing here is I'm taking my f function and I'm plugging it into my g function. Then I'm taking all of that and I'm plugging that into my h function. Now you just start one at a time. So I know that seems overwhelming, and even me, as I'm trying to think of that process through my head, it's like, wait a minute, what? Start it at one at a time. So let's start with that, our f function, and plug it into our g. So starting there, if I'm going to take my f function and plug it into my g of f of x, that's going to be, so my f function, and plug that into my g, that's going to give me 2 minus the square root of x squared minus 4x plus 3. So there's my f function, and it was plugged into my g function as a whole. So now what this is saying is you take this entire thing here, you take all of that, and you're plugging that into your h function. And so if I take that and plug it into my h function, I'm going to get 2 times 2 minus the square root of x squared minus 4x plus 3 over 2 minus the square root of x squared minus 4x plus 3 plus 1. And you'd have to go through the process of simplifying that to examining the domain, right? This is irrational, so now I can't divide by 0. I also have a square root, so my domain, I'm going to have values and I have to say it's greater than or equal to 0, but because it's the same rational top and bottom, exactly, I know, you're thinking, whoa, that's a lot, and it is. So, but just know that we can take that f, plug it into the g, take the g of f of x, you take all of that, and then you plug that into the h. The same process here, the thinking process. This is saying h of g of f of x. You take the f function, plug it into the g. You take the g function, and you plug it into the h. And then you would go through and you would do that process. Now in conclusion, start thinking about some of the things that we learned today. Now it's okay to pause, the lesson to kind of think about these things in both of these questions. But some of the things that we did learn was the composite of functions and basically the notation and how to write that. And for this last question, it says, imagine this composition, f of g of h of a of b of c. How could I verbalize the process? Now remember, you can pause it here, kind of think about it, think the process through, and then you can verify with the answer, which is, well, you take whatever c is, you plug it into your b function. You take whatever your b of c is, you plug that into your a function. You take whatever this is, you plug it into your h function. You take whatever this is, you plug it into your g function. Take whatever this is, you plug into your f function. And through that enormous amount of simplification that's probably going to be required, you would have your answer. Well, this does conclude our lesson. If you have any other questions, please leave them in the comments.